This is Habitsourcing, and I'm Henry.
I'm Katherine.
This is a joint work with Scott Cambo, Yongsung Kim, and our advisor, Haoqi Zhang. And this work was done in the Design, Technology, and Research Group as part of the Delta Lab at Northwestern University. So citizen science is a proven and effective way of getting members of the general public to contribute data about the natural world. There are numerous groups who benefit from this. Entrepreneurs can benefit from apps like Waze, where drivers can report real-time traffic conditions. Researchers can benefit from apps like eBird, where birders can track observations about species, and even the government can benefit from apps like CitySense, where citizens can report problems about their city. So the cool thing is that if you're interested in these domains and you're a user, you can actually contribute to the domain that you care about. But that's also kind of a limitation at the same time. Typically, the only people who do contribute to these domains are the people who are interested or who can benefit directly from it. So what are you supposed to do if you don't have interested volunteers?
So we see an opportunity in the millions of people who already go outside every day to practice habits such as running or going for a walk. For example, one popular app is Headspace, a meditation app that has 3 million users. And another example is Zombies Run, which is an app that entertains and motivates runners through a simulated zombie apocalypse. And this has around 200,000 active users. So it'd be really cool if we could utilize this group and leverage their regular routines and collect data about the environment. However, this is really hard to do because the users are primarily interested in building their habit, not in collecting data.
And that's where we introduce habit sourcing. And habit sourcing uses immersive interactions embedded within existing habit-building experiences to collect sensing data. And for that, we introduced 2 proof-of-concept iOS apps, ZenWalk and Zombies Interactive. And these apps are basically like the habit-building apps that we described before, but with these sensing interactions interlaced throughout.
So a main challenge in making habit sourcing work is that it's unlikely that habit builders are going to be willing to stop and manually record data. And this really limits the kind of interactions that we can ask them to do. So how can we gather data from people who are not intrinsically interested in collecting it?
So one approach to getting these kinds of indirect data contributions right now is physical games with a purpose. In physical games with a purpose, users don't really have to care about the data to collect it. Data is just collected as a byproduct of gameplay. And examples of this are Ingress, where users capture portals that represent landmarks in the real world, or Photo City, where users take pictures to kind of capture buildings, which are later used to reconstruct 3D models of these buildings. So physical games with a purpose do have some limitations in that users need to like games, and they also need to have time to play them. And furthermore, when they do play the games, you kind of need to go out of your way to collect the data in them by manually interacting in some way with the device. And to get around the difficulties of having these active interactions with the device, some approaches try to infer data passively. One example of this is Google Maps, which passively records location data to produce traffic information. But passive sensing kind of limited to the output of machine sensors that you have, and trying to infer activity based on this alone is really difficult, non-trivial, and you'd need complex machine learning algorithms typically. Furthermore, even then, there's no direct connection between the data sets you have and actual physical objects in the environment. So for this, we introduced sensing through actuation, which cues users to perform physical actions to elicit sensing data. And there are 2 major benefits to this. One is that we can avoid actually disrupting the user's experience during a habit because it's totally hands-free and all audio-based. And secondly, it becomes easy for us to extract and analyze data thanks to the kind of contextual ties we have to these traces. And we'll demonstrate that in a moment, but first we'll talk about where exactly you would put one of these sensing through actuation interactions within an experience.
So the user goes through a habit-building experience in a sequence of stages, and we insert sensing interactions into appropriate stages of the experience. So for example, a Headspace user might go through a meditation in stages that introduce them to the practice, help them focus on their breathing and posture, help them focus on their surroundings, and then reflect at the end. So it makes sense to insert a sensing interaction into the stage where, as a natural part of the meditation, the user is expanding their awareness to what's going on around them.
So we're going to show you a video, an example of a sensing through actuation in Zombies Interactive. And basically what you're going to see is our friend Jenny using the app and being taken through one of these interactions. And we'll just let it play.
Zombies in the area are gaining ground. You need to increase speed to reach a safe distance. Sprint until you pass a fire hydrant.
And that's basically it. So you can see on the right there is kind of a trace of the location, the GPS data, along with the speed, which is sort of color-coded into that. So, but how do we actually detect objects from... Where is it? So now that we have that data, how do we actually detect objects from it? Well, the good thing is that it's really easy. We don't need anything complex. We just need simple pattern detection. Thanks to knowing the context of the action that we queued, what exactly we should be looking for. In this case, all we know is that we told them to sprint until they reach a certain object, and we know that we should see them slowing down once they've reached it. So in this case, it's really easy to detect. And we're also going to show one for ZenWalk.
So this interaction takes place when the user is expanding their awareness to the environment around them. It's about a minute long, so we'll just play it.
Observe any trees near you, and bring your attention to any that you think look particularly pretty or interesting. Once you're near the tree, just walk around it slowly, in a large circle, observing its features from each side, appreciating the tree's presence and your presence with it. Continue to slowly circle the tree that you've found, and as you do so, focus your attention on its features.
So you saw that the user was cued to walk up to an interesting tree and observe its features from all sides, and this results in the person walking around the tree in a circular pattern. So from this pattern, we developed a simple heuristic that looks for dense areas of points in the user's GPS trace. So through sensing through actuation, we can make interactions that collect data, but we also need to make sure that they're enjoyable for a particular habit-building experience as well. So how can we do this?
So to figure out what kind of interactions work in particular domains, we went through a sort of iterative design process, and we go into more details about this in the paper, but we'll kind of give an overview of it here. So we recruited some representative users to test via like local Facebook groups, relevant subreddits, and we gave them these interactions. So here's what one looked like for ZenWalk that we started with. The user was instructed to just observe a tree and kind of walk around it. And we found that users said they didn't really know what to do. They were a little bit lost. They weren't sure what was meant by observe the tree, and they felt they needed more guidance. So in the next iteration, we had more specific details, like focusing on the texture of the tree bark, the shape of the leaves, things of that nature. Similarly, in Zombies Interactive, we started with an interaction that was meant to be immersive within the zombie apocalypse, and it told the user that zombies are chasing them, they should go take cover by a tree. While this would be a good one to collect data and kind of fits within the story, it actually doesn't work in habit sourcing because it's not really relevant to the habit. Users said that they didn't like stopping. Their whole reason that they're using running apps is to actually run. So in a later version, we had them just sprint to a building explicitly, and something that's more in line with what they're practicing.
So we ran 2 user studies. In the first, we looked at the question of whether people would use habit sourcing apps, because for habit sourcing to work, we actually need people who are willing to use the apps for their regular habit building practices. In the second, we looked at whether habit sourcing interactions can yield accurate data.
So we performed a within-subject comparison of 2 different versions of the app, and sort of what would be a habit-building app and what would be a habit-sourcing one. So the non-interactive version simply had stages that would represent like pure static audio that you would see in things like Headspace, and the interactive version had these sensing through actuation ones, like you saw in the video, interlaced throughout the experience. And each user received both versions in random order and received a post-study survey that asked them qualitative and quantitative questions about how enjoyable was each version, how likely are you to use each version in the future, and what generally worked well and what didn't work well. So again, in order to test a representative sample, we found representative subreddits, and we got 9 participants for ZenWalk and 12 for Zombies Interactive.
And from our results, we found that users preferred the interactive version more than or about as much as the non-interactive one, with Zombies Interactive participants liking the interactive version more, and ZenWalk participants liking both versions about the same. One reason that users liked the interactive version was that it increased their sense of immersion in the experience. For example, a Zombies user said that the cues to sprint made the experience seem more interactive, and also helped himself imagine himself in the actual storyline. And a ZenWalk user said that the tree circling interaction helped her connect with nature and also notice things that she otherwise might not have noticed. One aspect of the interactive versions that users actually didn't enjoy was when the interaction didn't match their context. So for example, a Zombies Interactive user was confused when the app told him that he might see a tall building, when in reality he was actually surrounded by a lot of different tall buildings because he was in the middle of New York City. As another example, a ZenWalk user felt socially awkward focusing on trees when there were a lot of people around her, because she was worried that other people might be judging her for focusing on a tree for so long. For the second study, we looked at the question of, can habit sourcing interactions yield accurate data? And we evaluated this on 2 different levels. First, can we accurately detect when a user performs an interaction? And second, can we accurately detect objects from an interaction's data trace? So because the purpose of this study was to evaluate accuracy of data rather than user experience, we used an abbreviated version that helped us recruit people and also was just much shorter to test. So for each experience, it contained 3 instances of sensing interactions. And we fed the sensor traces from each of those interactions into our object detection algorithm. And then we, in person, verified the detected object locations. We recruited a convenience sample locally from 18 participants, and we recruited locally because this enabled us to verify the collected data in person.
So in the post-study survey, one of the things we asked was whether each user performed the interactions that they were prompted to. And in almost every case, when the user said they did perform the interaction or when they said they didn't, we were able to kind of match that with our algorithm. And not only were we able to sometimes to detect these user actions, but in some cases we were also able to successfully identify these objects. As you can see, these are examples of outputs of the algorithm where the object was very close to where we believed that it would be.
One common failure case was when the object wasn't in the environment. So for example, if the user was asked to find a tall building when they were in a residential area without tall buildings, or as another example, when a user is asked to sprint past 10 trees and the area just doesn't have many trees. This was problematic because some users just didn't do the interaction because they didn't see the object, whereas others pretended like the object was there and just did the interaction anyway. And this made it hard to distinguish if there was actually an object there. And so from this we learned that we need to provide alternative instructions for all the different scenarios that the user might see. Another common failure case was when instructions just weren't specific enough. For example, there was an interaction that asked users to sprint past a fire hydrant, and it didn't specify how close to the fire hydrant they needed to be. This was problematic because some users considered fire hydrants across the street to be close to them, and for the purposes of data collection, this didn't work. And so we needed to specify how close to the object the user should be. So for example, 3 feet or a couple of meters.
So from these tests and studies, we came up with a set of general design principles for creating and designing these interactions. And pretty much every time the rule number 1 was to prioritize the habit building practice over anything else, including data collection. So while we really want to collect data, and that's kind of the whole reason we're doing this, it's also true that you won't have any users if they can't practice the habit, which would be the reason they are using these apps in the first place. Like Katherine mentioned before, considering social context, things that make the user feel uncomfortable are likely to provide them with a negative experience. Users enjoyed getting feedback when they performed an interaction. Being told that they completed something successfully made them feel more immersive and like they were actually being recognized rather than just being told a static audio prompt. And finally, interactions that don't make sense should be avoided. In the failure cases, we saw looking for trees when there are none around, or looking for tall buildings when they're actually everywhere. And if we can't avoid that, at least we should provide fallback instructions and some guidance. So there are a number of questions we'd like to answer about habit sourcing in the future. What kind of interaction techniques can we provide to make it more enjoyable and to yield better data? Can we scaffold collected data to achieve accuracy, coverage, and detail? By accuracy, maybe we would send someone to a location of a candidate that we found before to verify it. For coverage, we could kind of direct people away from known objects to get more, to cover more area. Or detail, we could send someone to an existing known object location and try to collect richer details about the same object. And how do we design new immersive experiences within the physical world? Once we have all this data from habit sourcing, we could use that for new interactions, both for habit sourcing apps, but also for any apps in general that you might be able to create immersive experiences for.
So in summary, we can provide a habit-building experience that's at least as enjoyable as existing ones. And we also saw that it's possible to collect accurate data, and we learned about what works well and what doesn't work well, which is pretty exciting because we can reach a broader population of people to contribute data as a byproduct of their everyday routines.
So thanks for your time, and to everyone else who worked on this paper, and if there are any questions, we'll answer them now.
Haoqi from KAIST. Really interesting work. I was wondering if there are certain properties for a habit that makes them work well for this kind of approach, as opposed to those that are not. Because I was thinking, these two apps you build make a lot of sense, but maybe there are certain types of apps where this kind of approach might not just work. So I was wondering if there are more sort of generalizable properties of tasks that we could look into, or if there are any specific applications beyond these you had in mind. Sharing those could also be really nice.
So I think the main thing that that we're looking for, or that these interaction principles kind of apply to generally, are habits that have you out in the environment, moving around. Generally, they're pretty reliant on motion. So something like, there are many habits that don't, such as knitting or something like that, that you can't really collect environmental data from. But we hope that anything that you can get out and about doing, that our design principles would allow you to design interactions for.
I have a quick question. It was a really great talk. I was wondering if you thought maybe these activities could potentially be kind of high stakes, kind of with the pizza and broccoli issue discussed earlier. Like, say, if you're asking folks to look at a tree while they're doing a meditation app, but then they might realize that this is like a little fishy when they're supposed to be kind of freeing themselves from the ails of the world, and then they're actually doing work for someone else, if it kind of conflicts with the interest itself. Does that make sense if you thought about how kind of the overlap of the work and the specific activity could create conflicts for the user or not?
Yeah, that's a great question. So basically, it's the design challenges in balancing enjoyability in the data collection, right? And so we found that it's important to prioritize the habit-building experience wherever possible. So yeah, things like circling the tree and people feeling socially awkward are things that wouldn't work well. And in order to overcome those challenges, you would need to design those interactions so that they are directly supporting the habit. So it needs to be directly related to the habit-building experience for it to work.
Right, and I guess the idea would be that as long as it fits properly into the habit-building practice, then there shouldn't be anything that conflicts directly.
Any other questions? All right, let's thank our speakers one more time.